Okay, question number 6. The initial kinetic energy of a block moving on the horizontal floor is 48 joules. Okay, so this is the floor. Let us say you're throwing the ball here. So this is at point A. So the initial kinetic energy is seen to be 48 joules. It's moving at a velocity u over here. Okay, a constant frictional force acts on the block, bringing it to rest over a distance of 2 meters. So therefore, the block comes over here. The block comes here, and its final velocity v is equal to 0 over here, and it's a constant frictional force. Something is opposing constantly. Okay. What is the frictional force on the block? So how do you do it? So what you do is, see, since when you say constant force, you can always apply equations of motion. So what we do, we can apply v square equal to u square plus 2as. Now what you do is multiply by half m on both the sides. Why do I do it? The reason is because I get half mv square here, and I get half mu square here, plus half m into 2a into s over here. So half mv square, since v is equal to 0, this becomes 0 over here. Half mu square, you already given, right? Which is nothing but the initial kinetic energy, 48 joules plus, and this 2 and this 2 goes away. I have m a into s. What is m into a? M into a is nothing but the net frictional force which is acting in the backward direction. We can always reason saying that, hey, how can this be a m into a? M into a is nothing but net force, okay, which is according to Newton's second law of motion also. Let me go with that, because we already learned frictional force is equal to something like mu times n. But where is that? I am not applying over here, right? You can always argue with that. But even after writing like this, what do you do actually? You write this as a frictional force equal to mass into acceleration. What is the net force acting? There is no forward force acting here. Okay, there's only a backward force acting over here, which is nothing but m into a. Okay, so you can apply this one even for frictional force. So it is already said it's a constant frictional force is applied. So what is that you need to find? You need to find out this value. We'll do one thing, instead of writing this, if it confuses you, so I will write this as a 48 plus frictional force multiplied by s. Okay, what is a s here? S here is nothing but 2 meters. 2 meters over here. And this value should be negative. Why negative? Because it's opposing, right? I'll write this as minus over here. So when I do this, what do I get here? So I get frictional force into 2 is equal to 48. Frictional force should be equal to 24 Newton. Thus the answer is A. Okay.